Our environment and how we consume media has changed drastically. Gadgets we didn't have 10 years ago are now ubiquitous. Complex fluorescent light bulbs are mandated, and screen time for everyone from toddlers to great-grandparents is at an all-time high and rising. High-energy, visible blue light is a hot topic among eye care professionals, industry, and patients. Hoyle will use science to demonstrate the high-energy, visible blue light story for the purpose of clearing up a misconception permeating the market.
Okay, so this is a representation of all the colors of the rainbow from sunlight, starting at 380 nanometers and going through all the colors of the rainbow. And the spectrometer is aiming upward at the sky. This is a screen, and this is what's coming off of our devices, iPads, smartphones. And you can see the amount of blue light is the greatest amount that's coming off these devices.
Dr. Gosling was using a spectrometer developed by Perfect Square in conjunction with the app Spectrop. Let's quickly review what blue light is. Blue light is part of the visible light spectrum. It has always been with us, primarily via the sun. Blue light is important, and we do need some exposure to blue light. Although high amounts of blue light exposure has an impact on visual acuity in relation to scatter and haze, and has been associated with contributing to age-related macular degeneration, blue light also affects our circadian rhythm or sleep pattern. While we do not know all the long-term effects of overexposure to high-energy visible blue light, we can take protective measures. Let's take a look at what's available. We'll start by looking at blue light in the 380 to 420 range, which is primarily associated with scatter haze.
And then this is the polymer, the new polymer, and we're looking at light between 400 and 410 nanometers right in this box itself. So first we'll capture this, and then we're going to place the lens on top of it, and then we're going to recapture it, and now we'll compare the two. We're getting a difference of 52% reduction in intensity between 400 and 410 nanometers. This is Blue Tech, and we're again measuring between 400 and 410. So we'll first again capture this, and now placing the lens on top, we will recapture, and then we'll compare. And we're getting an intensity of 52% intensity drop. So here's recharge, and again we're concentrating between 400 and 410. So we'll first capture. Now we'll place over the spectrometer, recapture, and compare an intensity drop of 19%.
Now let's take a look at blue light in the 420 to 460 range, which is primarily associated with the increased risk of age-related macular degeneration.
So now we're going back to the polymer, and we're concentrating on here between 430 and 450, most dangerous wavelengths to the eye. We're going to capture, placing it over the spectrometer, and then we'll recapture, and then we're going to make the comparison. An intensity drop of 3% between 430 and 450. This is Blue Tech lens, and again we're concentrating on the 430 to 450 range. So we will begin by capturing, placing the lens on top, and recapturing, comparing, getting intensity drop of 15. This is the recharge. Again, we're concentrating between 430 and 450. So we will just clear this, capture, place the lens on top, recapture, make the comparison, 9%.
Finally, we'll look at blue light in the 460 to 500 range, which has an impact on our sleep patterns or circadian rhythm.
Now we're concentrating back on the circadian rhythm area between 460 and 480. Again with the monomer. I'm going to be first capturing this and placing it on top, recapturing, and making the comparison. 2%. This is the Blue Tech lens. Again, concentrating between the 460 and 480 range. We'll first capture and making the comparison. 9% drop. This is recharge. And again, we're concentrating between 460 and 480. We'll begin by capturing, placing it over the spectrometer, recapturing, making a comparison. 4% reduction.
Most lens manufacturers are marketing blue light blocking lens treatments and materials. The most common demonstration involves the lens sample and a blue light laser pointer or presentation pin. These pins are 405 nanometers and are readily available and very cheap for most office supply stores and websites.
So this is a 405 nanometer demonstration pointer that can be purchased fairly inexpensively online. Here is the monomer lens, and we want to first show the 405 on the paper. Remember that monomer was really knocking down a lot of the wavelength between 400 and 410, so when we place it on top of it, it definitely knocks it out. That's its concentration and its focus. Bluetech also does a great job with the 405 nanometer monomer, and when we place it over, it knocks out a significant amount of the blue light, as we had demonstrated with the spectrometer. But it also does a good job at knocking out the 430 to 450 range as well. Okay, again, this 405 nanometer wavelength is only one wavelength of many in the high energy visible blue light spectrum. If we take recharge, we mentioned that it only knocked 19% down, so you'll see it does not knock down as significant amount as Bluetech or the monomer itself. But it does its main focus on the 430 to 450 range.
In effect, the product readily fits a prefabricated demonstration tool. Unfortunately, this demonstration tells an incomplete story. The mission of this video, and the ally of the independent practice, is to disseminate complete information regarding the effectiveness of various blue light lens materials and treatments in 3 areas that impact vision and eye health: scatter haze, age-related macular degeneration risk, and sleep patterns. Please be cautious. Do not jump to conclusions based on one wavelength demonstration. Be aware of the full effect of high-energy visible blue light. Let's look at one last demonstration.
So right now the spectrometer is aiming up this lamp right here, where there's a compact fluorescent light bulb. And you can see what these compact fluorescent light bulbs are made of, these spikes, with the main spike being at 435 nanometers. I have it boxed in here between 431 and 438, but that spike is roughly at about 435. And you can see different light sources emit different frequencies of wavelengths of light. I have the Bluetech lens here, and I'm going to be placing it in front, again, focusing on this 435. So basically, I'm going to clear this out, capture it, place the lens on top, recapture, make the comparison, and we're getting a reduction of 33% of that harmful blue light at that 435 range. So again, here we're looking at the 435 range, and we're going to be using the monomer now. I'm going to be first capturing, then placing the lens on top, and then recapturing, and making that comparison of a reduction of 4% at 435. So again, we're looking at the 435 range with the compact fluorescent light bulb. I'll capture it. We have recharge now. I'll place recharge in front of it. I'll recapture, and we're getting a comparison of 19% reduction.
That was amazing. Thank you, Dr. Gosling, for methodically taking us through each part of the high-energy visible blue light and demonstrating the protection available from various lens materials and AR treatments on the market. There are 3 distinct parts to the high-energy blue light story which cannot be told with a slick sales demonstration. When your patients come to see you with symptoms related to digital eye strain or other risk factors, they are seeking your expertise and your prescribed solutions based on science.